Okay, I'm going to go over number one on the warm-up really quick. And once again, you guys already know the process that I use. Some of the skills that I include on the warm-ups are part of some of the lessons that are coming up. Since today we're going to close Unit 1, which is module on functions of absolute values. Tomorrow we get started with quadratics already, Unit 2. But it shouldn't be a surprise in regards to some of the skills that you need, because we've been doing a lot of that stuff in the warm-ups, okay? But here's another skill that I want to revisit. You guys should know how to do this. However, I'm going to go over this one more time to make sure everybody's clear as to what we're doing with simplification of radicals. Here it goes. Writing utensil down, look up to the screen. When they ask to simplify square root of 20, in the past I showed you guys how to find the decimal equivalent. For the purpose of the lessons that we're going to cover, we're no longer going to be looking at decimals because it's not an exact amount. It's usually approximate. When you leave it as a radical and simplify as a radical, that's called an exact amount. So here's the process. First things first, we need to think about two factors that make 20. What does that mean, Mr. Q? Two numbers that multiply each other. That's what factors mean. Two numbers that multiply each other to give us 20. All right, well, we got 2 times 10 and 4 times 5. So, and 1 times 20. However, the rule is, in order to simplify, we need one of the numbers to be a perfect square. You're saying, what is a perfect square, Mr. Q? A perfect square is a number like this: 1, 4, 9, 16, 25, and so on and so forth. And so you're saying, how did you get those, Mr. Q? Well, what is 1 times 1? 2 times 2. 3 times 3. 4 times 4. 5 times 5, and so on. These are perfect square numbers. So which pair of factors give me the perfect square number? 4 times 5. So this can be rewritten as square root of 4 times 5. And this is very similar to when we did imaginary simplification of imaginary numbers the other day, remember? From there we can rewrite it again, square root of 4 times square root of 5. Are we there so far? So what is square root of 4? 2, and square root of 5, and we're done. That's it, because the 5 is a prime number, we can't factor it anymore. Fairly simple? Okay. I'm going to give you one more for you to do by yourself. Let's see how you do with that. Here it goes. Example Q. Simplify square root of 50. Don't say it out loud. See if you can find the two factors. Yes, right in the warm-up. I'll give you guys about 40 seconds. Copy and go. Okay, here goes the process. So, pairs of factors of 50. 1 times 50, 2 times 25, 4 times 3 times, 5 times 10. 5 times 10. Which one of those pairs has a perfect squared number? 2 and 25. So this becomes square root of 2 times 25. We can rewrite this as square root of 2 times square root of 25. What is square root of 25? 5 square root of 2. And have you got that? Okay. All right. Well, I'm going to give you these all week, but what I'm saying, they're coming up already in the lessons that are coming up probably by Thursday. We're going to be using these already. Okay? Next, B. It reads, simplify. Writing utensils down, look up to the screen. Very similar to what we just did, but now it's using division. Here it goes. First, I'm going to rewrite it. This becomes square root of 4 over square root of 5. What is square root of 4? 2 over square root of 5. I'm not done though. Now check this out. Why am I not done, Mr. Q, if this is a prime number and I can't simplify that anymore? Okay, let's analyze this. Here it goes. We have a integer over a radical that can be simplified. Do you agree if I was to simplify this, it gives me a decimal approximately? Yes. So in a fraction, we cannot have fractions divided by other fractions. It would look weird. Kind of like saying this, 5 over 3/4, a fraction over another fraction. You know what I'm saying? Because that's part of the definition that we were given by our algebra teacher back in 8th grade. Let's see if you guys remember. Here it goes. Those of you that were with me. I said, there's a definition for fractions that starts with the letter Q. The letter Q stands for quotient, which is division, also known as rational numbers. Rational numbers is the set of all fractions that look like this, m over n, such that m is an integer, n is an integer, is an integer. However, n cannot be equal to 0. That is correct. So you remembered. And you're saying, what? Okay, here it goes again. Q stands for fractions or rationals. Rationals are numbers that are decimal or fractions. So here's a fraction. Now I'm going to use numbers. If m and n are integers, what numbers are integers? All the negative numbers and all the positive numbers, all the way to infinity, all the way to negative infinity. Do you agree with that? So that means n could be any of those numbers. Does it say anywhere that n can be a fraction or a decimal? No, the denominator cannot be a fraction or a decimal, or 0. It cannot be 0. Therefore, now that I showed you the definition, here it goes. We cannot have this on the denominator. So what can we do, Mr. Q? I'm going to show you a step called rationalizing the rational. You're like, what? Just pay attention. Here we go. We're going to get rid of the radical on the denominator. How do we do that, Mr. Q? By multiplying it by itself. And whatever we do to the denominator, we do to the numerator. So this becomes 2 square root of 5 over, what is 5 times 5? Square root of 25. Therefore, 2 square root of 5 over, what is square root of 25? 5, and now it's simplified. Copy that, please. All right, so what's the key here? First step, we need to write it individually, the numerator and denominator as a radical. Simplify whichever can be simplified. And from there, if we have on the denominator a radical, we multiply top and bottom by the same radical. And that'll give us the product on top. And this will be the same number times itself. It gives the square root of that number squared. And then square root of that number is that. All right. Example, super cube. You do this one. Square root of 9 over 2. I'll give you 40 seconds. Copy that and go. All right, so here goes the process to make sure we got it. We rewrite this first as square root of 9 over square root of 2. What is square root of 9? 3 over square root of 2. Can we leave it as a radical in the denominator? No, so we multiply times the same, square root of 2, top and bottom. This becomes 3 square root of 2 over 2 times 2 is square root of 4. This becomes 3 square root of 2. What is square root of 4? 2. And if you got that, let's go from the corner. We got it, yeah? All right, so that's what we're going to be practicing all week, and that's what's coming up on the following lessons. Next, any questions with number 2? With a sum, difference, or product? Guys, remember, you need to know these processes automatic. It should be like second-hand by now. Yeah, sum is adding, subtracting, and multiplying. Now, why is it so important to know this, Mr. Q? Because we're going to start substituting imaginary numbers and making complex numbers. If you have any doubts with the process, you're going to start getting confused. We got this? Yes? I'm going to give you just a look ahead as to what it's going to look like with imaginary numbers. If I was to multiply these two, we know what the process is. However, let's say I substituted x but with an imaginary number. 6i minus 8 and 9i plus 10. And the process is the same. Turn it off, please. So that's why if we know the process, all we have to worry about is the simplifying of the imaginary numbers towards the end. Does that make sense? All right. Same thing with factoring. We're about to get into solving quadratic equations and functions. You need to know the process. And do I need to show you the graph for f of x equals absolute value? Everybody show me with your hands what it looks like. Cocoa part. Yeah, like this, like a V, yes? All right. All right. So, with that said, let's move on. Copy your home plate for tonight. It's only 10 problems. It sounds very little when you say only, right? There you go. Copy those, please. Hey, I gave you guys a break over the weekend because of HOCO. All right? Yeah, this will take you but a fat minute to do, yeah? Yeah, copy that, please. All right, sounds like we're ready to go, yes? All right, so once again, your home plate for tonight is only 10 problems. It says plot the vertex of the function, then graph the function without a table. Today I'm going to show you the actual process, and I want exact points that belong to the function, not anymore just trying to guesstimate what it's going to look like. That's what I wanted you guys to know last week. Today we're going to finalize with an actual product that is exact. Okay? Yes, you will need a graph for your home plate. All right. So for today, we're not going to need Cornell notes. Let's use our graphing paper. So our objective for today, I can graph and write absolute value functions. Yes. Our objective for today, I can graph and write absolute value functions. So if you notice, we're still on functions, and we are finishing up our absolute values. And today will be the last lesson on that. However, is this the last time we're going to look at them? No. In November, once we have our mid-quarter assessment coming up, it's going to be all in there, including everything that we saw in the first quarter, including everything that we're going to see coming up with quadratics. Okay? So please, pretty please, don't fall behind. If you need to start attending tutoring because of the imaginary and complex numbers that are coming up, come after school. It's free. Or let me just say it like with a slide. Here we go. Ready? It's free. Oh my goodness. Yeah, it's like I keep saying it, and people are like, they come in and all of a sudden, this is you. I need help. Really? Well, I've been telling you to attend tutoring. Oh my goodness. So, here we go. We know what functions are? Yes? All right. So we're going to start with an activity that requires us to look at these three. And however, we're not going to do all of them together, each one of us doing all three. We're going to split this up. So let me do this. Get your colored pens ready. I'm going to do the top one in blue. The top one, pay attention to this part. From Zod's row, that way, you guys are going to copy this one, the first one in blue. Copy it on the top left of your graph paper. Next. From Ethan's row this way, you guys are going to do the last one. Copy this one on the top left of your graphing paper. And the middle one's going to be in green, and this one's for the middle row, Chance's row, and I'm going to be in your team. So we're going to do this one in green, okay? All right? So just copy it, and then my team's going to show you how to fill out the table so we can graph that and do the process, the whole process. the way we used to do the process, okay? So, my team, here we go, in green. So we need to work on g of x equals absolute value negative 1/2, parentheses, x minus 5, close absolute value minus 2. So here in the second quadrant, I want you guys to write x, well, g of x. My bad, hold on. Oh my goodness. Be nice. Boom. There it is. All right. So my team, we're going to do the first two so you guys can see the process so that you can do the same with yours. Here we go. So I'm going to start with negative 2. You guys ready? Chance? Here we go. So if we substitute negative 2 here, we get what? Negative 2 and negative 5. That gives us what? Negative 7 inside of parentheses. Do you agree with that? All right. Next, the parentheses indicates that we're multiplying that times negative 1/2. So what is negative times a negative? Positive. So this became positive, okay. 7 times 1/2 is 7/2, or 3.5 in the absolute value. Are we there so far? Yeah. So what is the absolute value of 3.5? 3.5, and at the end we need to subtract 2, so that leaves us with 1.5. Did everybody see all the process? Yeah. Next value, negative 1. All right, let me erase this from here. Now I'm going to substitute negative 1 in here. So what is negative 1 and negative 5? Negative 6. Negative times a negative becomes a positive. 6 times 1/2 is 6 over 2, which is 3. What is the absolute value of 3? 3 minus 2 is 1. Does everybody see what I'm doing over here? Okay, so those of you in blue, copy your table there and start doing the same. Those of you in red, start doing the same. But you use the process that you were given. All right, my team, continue. The next value is 0, and the last value that I want us to plot is 1. Focus, please. All right, let's see. When x is 0, what you get when x is 0, Catalina? You haven't done it yet? Paul, help her out. 0.5, that is correct. 0.5. All right. How about when x is 1? What do you get for x is 1, Ramon? 0. Okay, let's plot those points, yes, in green. Negative 2, 1.5, negative 1, 1, 0, half, 1, 0. All right. Chance, by looking at it, what's our, Yeah, for right now, just 4. But what else do we need? Vertex. What's our vertex, Chance? Positive 5 and negative 2. That is correct. So let's plot that. Positive 5, negative 2. All right. And then from there, if we were to be doing the old process, what would we do? We would draw an imaginary line of symmetry and then reflect the points. This one is how many steps away from the line of symmetry? 1, 2, 3, 4. 1, 2, 3, 4. Then this one right there, this one right there, and this one right there. So here's that, and here's that. All right. All right, let me go with the blue team. Let's see. X, g of x. All right, when x negative 2, Clarissa, what'd you get? 1.5. when x is negative 1? Danny. When x is 0? Zab. 0.5. And when x is 1, what'd you get, Leo? 0. Wait a minute.
No.
Let me go with the red team. X, g of x. Alexa, negative 2 is what? 1.5. Damien, negative 1 is 1. 0. Jacob. Okay, 0.5. The other Jacob, 1 is 0. Can you remember what you guys notice? It's all the same. So some of you are saying, Mr. Q, but how is it the same? Okay, so what am I trying to convey? That it doesn't matter if we have a fraction outside or inside, we're going to get the same function as long as the vertex is the same. However, this is what I want you guys to understand. Look up, please. Tell your neighbor, why even if this one has a negative inside the parentheses, it didn't matter, we get the same thing. Talk to your neighbor. It would be different. Yeah. So, Kenzie, what's your neighbor say? Why didn't it matter? Because the absolute value, it always comes out as a positive. Now, Zab asked a very important question. He's off. Mr. Q, what if this one had a negative like that? Well, then that will make a difference. It would be the same function. However, it would look how, everyone? Inverted, because of the negative value outside. Okay? So, any questions with the process that we did before? All right, so today I'm going to show you the fast process. Ready? Here we go. Writing utensils down, look up to the screen. Here we go. Look up, guys. Writing utensils down, look up. Here goes the easiest process ever for graphing functions. Step 1. Step 1. I need to identify the vertex. Vertex is 5, negative 2. 5, negative 2. Focus, please. Here goes the doozy on this one. Next, I need points. Well, if I was to look at this like a linear equation, what does that look like? Rise over run. That means 1 up, 2 to the right, 1 up, 2 to the right, 1 up, 2 to the right. If that's true, and this is the vertex, that means I can go 1 up and 2 to the left, 1 up, 2 to the left, 1 up, 2 to the left, and there's our function. Yes, we could have, but if you guys know me better, those of you that have been with me, do I give you the easy method first? No, you need to know the other stuff. We need to understand the line of symmetry. We need to understand how to graph, where everything is in regards to transformation. But now that we know all that, now you know the shortcut. Yeah, but 10 pounds wouldn't take you more than 30, 40 minutes. Everybody with me? What? 30 minutes? Anyway, all right, so go to your graph paper, to the new coordinate plane. Write example number 1. Doesn't matter if it's on the other side, just a new coordinate plane. Copy this function. G of x equals 4 times x minus 5, absolute value, minus 2. I'm going to use red for this one. You can use whatever color you want. So, everyone, what is our first step? Vertex. All right? Our vertex is, everyone? 5, negative 2. 5, negative 2. There it is. Make sure you make that point a little bit bigger so that you know that that's where you're going to mirror both points. Next, look at it. What number do we have either inside or outside next to x? A 4. So my slope is 4 over 1. That means 4 steps up, 1, 2, 3, 4, 1 to the right. Do it again. 1, 2, 3, 4, 1 to the right. And then I go back to the vertex and go 1, 2, 3, 4, 1 to the left. 1, 2, 3, 4, 1 to the left. And there's our function. All right, we got this? Yes? All right. On that same coordinate plane, let me move this up so I can give you another one. There it is. I'm going to switch colors to blue. On the same coordinate plane, I want you to graph g of x equals, let's do, okay, 2 times x plus 7 minus 5. Copy that and see if you can graph that. You got 40 seconds. Go. Let's see. Let me move this up a little bit. What's our vertex, everyone? -7, -5. That is correct. So, -7, -5 is right there. What is my slope, everyone? 2 over 1. That means 2 up, 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right. Go back to the vertex. 2 up, 1 to the left, 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 2 up, 1 to the left. And there's our function. Hands if you got that. We got this, yes? Okay, let's do another one. Here we go. You can do this on the new coordinate plane. Do this one in green. How about green? Yes? All right. G of x equals -2x. I'm sorry, -2 times the absolute value x plus 9, close the absolute value, plus 3. 40 seconds. Ready? Copy that and go. All right, here we go. We said green on this one, Chance? All right. Vertex, everyone. -9, 3. That is correct. So we go to -9, 3. It's right there. What is our slope, everyone? That means 2 steps down, 1 to the right. 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 Go back to the vertex. 2 steps down, 1 to the left. 2 steps. Did I skip a step? Yeah, I skipped a skip. Be nice. Step. There it is. There and there. All right. There and there. Hands if you got that. Okay, we got this, yes? All right, so let me point something out really quick before I crank it up a notch. Ready? Here it goes. Look up, please. First of all, who noticed that on the first one that we did, look up to the screen, please. X minus 5 were in parentheses. That's why we can identify that the vertex was 5, -2. Are we there? From there, we moved on to this one. X minus 5 were by themselves inside the absolute value. That's where we can identify that the vertex was 5, -2. Here, x plus 7 was by itself. That's where we identify that -7 and -5 was the vertex. And this last one, x plus 9 was by itself. That's why it was -9 and 3 the vertex. Are we there? Yeah. Okay, here goes another one. Copy this one. File number, okay, good. Number 3. Yeah, this one you could do it on a different coordinate plane. G of x equals, and this one any color that you want, G of x equals absolute value 2x minus 10, close the absolute value minus 3. Don't say it out loud, let people think, please. This one does have a little curveball, see if you catch it. 30 seconds, no, 40 seconds. Copy and go. All right, here it goes. I'm going to do this one in blue. Vertex. 5, negative 3. Who caught that one? Yes, if you notice this one, these were not in parentheses and it has a 2. That means I need to write this as 2x minus 10 equals to 0 and solve for x. That's going to be my h. Plus 10 plus 10, 2x equals 10 divided by 2. X equals 5, and there's my vertex. Okay, 5, negative 3. Next. Now pay attention to this part. This is where some people get confused. And I ask, what is our slope? Okay, did we simplify at all this function? No. So by looking at it, what's our slope? 2 over 1. 1, 2, 1 to the right, 1, 2, 1 to the right, 1, 2, 1 to the right, 1, 2, 1 to the right. Go back to the vertex, 1, 2, 1 to the left, 1, 2, 1 to the left, 1, 2, 1 to the left, and our function. All right? Tell me if we finish out some PR with these 5s. Okay, let's do one more. Here we go. Let's crank it up a notch. You can use, let's see. You can use the same coordinate plane. Write this down. G of x equals 3 over 2 times the absolute value x minus 5, close the absolute value, plus 4. 45 seconds. Copy that and go. All right, here we go. I'm going to use red for this one. Vertex. 5, 4. 5, 4. Slope. 3 up, 2 to the right. 1, 2, 3, 1, 2, plot your point, do it again. 1, 2, 3, 1, 2, plot your point, do it again. 1, 2, 3, 1, 2, plot your point. Let's go back to the vertex. Do it again. 1, 2, 3, 2 to the left, plot your point, do it again. 1, 2, 3, 2 to the left, plot your point, do it again. 1, 2, 3, 2 to the left, plot your point, graph your rays. Here's one ray. And here's the other ray. Hands if you got that. Okay. All right. Do we need one more? All right. So once again, the home plate for tonight, not Fortnite, is these 10. There is tutoring today, so make sure if you still have questions, be there. It's free. Good one, guys. See you guys tomorrow. Bye.